Hey guys, today we're going to be looking at quadratic sequences and how to work them out using algebra. So, let's get started. This is what a quadratic sequence looks like. Something multiplied by n squared plus or minus something multiplied by n plus or minus something. So, these three circles are unknowns, and we don't know what they are. So instead, we replace them with algebraic terms. So you just put a, b, and c. So that would be a n squared, then b n, and c by itself. And then, of course, we have plus or minus, plus or minus. Now, using this, we can write out a quadratic sequence and what pattern that it follows. So, if we note that this here, I'll just put it as plus for now, will be our quadratic sequence, then we know what the first term is, what the second term is, third term, and so on. So, let's write this out. 1, 2, 3, 4, 5. And remember that whenever we're counting terms, that the number term is called n. And so to find all of these terms in these positions, we can just use the same formula, well, the same expression, and substitute n for all of these numbers in their positions. So, for example, the first one would be a multiplied by n squared, but in this case, n is 1. So 1 squared is 1, and so therefore that would be a1, and therefore it would be 1a, and therefore it would be just a. Then you move on to the next one. b times n, but it's actually b times 1 because we substitute n, we substitute n for 1, so we b1, and in that case it would be 1b, and in that case it would be just b. And then finally we just have c, so there you go. So, the first term would be a plus b plus c. A plus b plus c. Now we move on to the second term. We're going to substitute n for 2 this time. So it would be a2 squared plus b2 plus c. And c doesn't change at all because c is not multiplied by n in any way. So it's not affected by the nth term. And so what we do is we take 2 squared and we change it to 4, 2b, b2, and we change it to 2b, and leave c where it is, and therefore that would be, the first term would be, instead of a4, 4a. So now we know this is 4a plus 2b plus c. And if you continue this, you will be able to find any term, the algebraic expression for any term. So for example, 3 would be 9a plus 3n plus c. The next one would be 16a. Oops. Yeah, sorry, that was meant to be b over here. 16a plus 4b plus c, and then 25a plus 5b plus c. I apologise for my absolutely terrible handwriting, even though I'm using an Apple Pencil. So I do apologise for that. And quadratic sequences are known for what? They're known for their second differences. So if we calculate the algebraic differences between these, we get 3a plus b is the first difference. Then we get 5a plus b. then we get 7a plus b, and you can kind of see the pattern now. But yeah, so 9a plus b, and then the second difference is always 2a. Oops, 2a, 2a, 2a. So, what can we do with this? Well, looks cool and everything, but well, how's it even useful? Well, I'm about to show you. And we'll get started with our first problem. So, first we're going to be given a quadratic sequence as our question. So, what should we do? We'll do 5, 17, 35, 59, 89. So, first we're going to find the difference of these and work out what it is. So, this is 12. This is, hold on, let me work it out. I'm not that good at maths, and I'm joking. This would be 24, and this is 30. Please do excuse me if I do actually get something wrong, because I am studying the current topics, and yeah. So yeah, please do excuse me, and also tell me in the comments if I have messed something up. But yeah, so we have this sequence. So now, how do you work out what the quadratic sequence is, or the nth term is? So we use our algebra. We know that this term here is the same as 3a plus b. So 3a plus b equals 12. Then we know that this is 2a. So the second difference is 2a. So therefore we know that 2a equals 6. Then we need to work out what c is. So we know that the first term is a plus b plus c. A plus b plus c. And a plus b plus c is equal to this first term over here. So these two over here. So a plus b plus c equals 5. So how do we work out what a, b, and c are? Already we can write out n squared plus, actually we can't write in the plus yet, but then n, and then plus something, or minus something. So we can already write those terms in, and we just need to find the coefficient of n squared, the coefficient of n, and then the final number that's added on, if there is any. And so we know that if 2a equals 6, then we divide both sides by 2, and we get a equals 3. And so now we know that a equals 3. And what is a? Well, in n squared plus bn plus c, a is the coefficient of n squared, and therefore this 3 would go right here. 3n squared. So you already know that it's 3n squared. Now what do? We know that a is 3. So therefore, if we go to this equation, this equation in black, just above the red one, we can see that 3a plus b equals 12. And if we just move this to one side, 3a plus b equals 12. And therefore, 3 times 3, because a is 3, 3 times 3 is 9. So it would be 9 plus b equals 12. Now, we take away 9 from both sides. And so then we get b equals 3. So now we know that b equals 3. And again, in our expression, we know that b is the coefficient of n. Just n, not n squared. And so we can take this 3 and drag it up here. And then we get 3n squared plus 3n. And we know it's plus because if it was minus, then this over here, this would be negative 3. So it's plus 3n. And finally, how do you find c? Well, we know that a plus b plus c equals 5. And so if we know that, hold on, where should I put this? I'll put it above. Drag up here. If we know that a plus b plus c equals 5, and we know that a is 3, and b is 3, then we know that 6 plus c equals 5. But how could 6 plus c be 5? If 6 plus a positive number would give you a lower number. Well, this is because we're adding a negative number. And so c would be negative 1. Remember that when you add a negative number, you're actually taking away. So 6 plus negative 1 would give you 5. And therefore, c equals negative 1. Again, we can do this a different way. So if we know that 6, if we just drag this up here, 6 plus c equals 5, then we can bring this round to here, take away 6 from both sides, and therefore it will give you c equals minus 1 again. Now, if we know that c equals minus 1, then we can just add this into our nth term, and so we know that it would be not plus minus 1, but instead it would be just minus 1. So, our final answer is, after all this, our final answer for the nth term would be n squared. Yep, I said n squared. It's actually 3n squared. Plus 3n minus 1. And this is how to find the nth term of a quadratic sequence using algebra. I hope you enjoyed this, and once again I will be back with more maths videos, so please subscribe, like the video, and I will see you next time, hopefully. Bye!